Throughout the history of aviation, one of the most important technological achievements has been the development of jet engines. Jet engines have experienced significant transformations throughout their history, beginning with the primitive turbojets that powered early aircraft and progressing to the complex turbofan engines that powered modern commercial and military aircraft. These modifications have served to improve performance, fuel efficiency, noise reduction, and environmental sustainability. Within the context of jet engine technology, this video traces the most significant advances, with a particular emphasis on the transition from turbojets to turbofans and beyond. 1. Early developments. The beginning of the turbojet generating process. The turbojet engine, the initial stage of development. The development of the first generation of jet engines, known as turbojets, occurred during World War II and stood out as a significant step forward in the field of aviation. Turbines are used in the operation of turbojet engines. These turbines compress air, combine it with fuel, and ignite the combination. The mixture then rapidly expands and escapes out of the nozzle, which results in the creation of thrust. The design of turbojets was rather straightforward, consisting of an air intake, a compressor, a combustion chamber, a turbine, and a nozzle. This was one of the key features of turbojets. Turbojets were a huge upgrade over piston engines at the time, enabling better speed and altitude capabilities. Fuel efficiency. At the time, turbojets were a significant improvement. Restriction. Even though turbojets were able to achieve higher speeds, they were inefficient when traveling at subsonic speeds. Additionally, they generated a significant amount of noise and heat, which made them less acceptable for use in commercial aviation. Examples: the Rolls-Royce Welland. This was the first British turbojet engine, and it was built for the Gloucester Meteor, which was the first operational jet fighter in the world. During World War II, the BMW 003 was a pioneering German turbojet engine that was utilized in the Heinkel He 162 jet fighter. The development of turbofans is the second advancement in this category. During the 1950s and 1960s, turbojets had established themselves as the standard for both military and commercial aircraft. However, it became clear that turbojets had efficiency constraints while operating at cruising speeds. This resulted in the development of turbofan engines, which offered improved fuel efficiency, decreased noise levels, and increased dependability. A turbofan engine is what exactly? The turbojet engine has evolved into a turbofan engine, which also goes by the name turbofan. There is a sizable fan located at the front of the engine, which is responsible for creating the majority of the thrust. The turbine is responsible for driving the fan. However, a significant portion of the air can circumvent the core of the engine, which results in increased fuel economy. Key features: bypass ratio. One of the defining characteristics of a turbofan is the bypass ratio, which refers to the amount of air that bypasses the core of the engine compared to the air that flows through the engine's combustion process. A larger bypass ratio leads to increased efficiency as well as a more silent operation. When compared to turbojets, the bypassed air generates more thrust without requiring the use of fuel, which results in improved fuel efficiency and a more silent operation. Noise reduction. The bypassed air also serves to reduce the noise that is created by the main engine, which is one of the reasons why turbofan engines are significantly quieter than turbojet designs. One of the earliest turbofan engines to be used on commercial aircraft, the Pratt & Whitney JT3D, was utilized by the Boeing 707 and the Douglas DC-8, among other commercial aircraft. The Rolls-Royce Conway was the first commercial turbofan engine ever built. It was utilized in aircraft such as the Boeing 707 and the Vickers Aviv C-10, among others. 3. High-bypass turbofans, the turning point in the transition to commercial aviation. In the 1970s, the commercial aviation industry saw a significant transformation as a result of the introduction of high-bypass turbofan engines. In these engines, the fans were substantially larger, which resulted in a huge increase in the amount of air that was able to bypass the engine core. Not only did this move result in more efficient engines, but it also resulted in engines that were more ecologically friendly. They produced fewer emissions. Key developments in high-bypass turbofans: more efficient fuel usage. High-bypass turbofans can generate more thrust for the same quantity of fuel, which makes them best suited for long-distance flights. Larger engines. These engines became significantly quieter as a result of the larger fans, which helped to reduce the amount of noise pollution that is connected with air travel. The increased fuel efficiency resulted in huge cost savings for airlines, while passengers benefited from flights that were quieter and more comfortable. The economic impact that this had was significant. Examples include the following. The CFM56 engine, which is a product of a partnership between General Electric and Snecma, is used to power a wide variety of commercial aircraft, such as the Boeing 737 and the Airbus A320. Because of its high bypass ratio and extremely good fuel efficiency, it quickly established the standard for contemporary turbofan engines used in commercial applications. An example of a Rolls-Royce Trent 900, one of the more contemporary high-bypass turbofans, which can be seen on the Airbus A380. By utilizing high-bypass turbofans, this engine is a prime example of the advancements that have been made in terms of power, efficiency, and noise reduction. Fourth, contemporary innovations, promoting environmentally responsible aviation and the prospects for turbofans. Jet engines continue to develop alongside the progression of aviation. Not only is there an emphasis on enhancing power and fuel efficiency in the present day, but there is also a focus on sustainability. New technologies are being created to tackle the issues that are being faced by the aviation sector, which is the subject of rising pressure to minimize its carbon footprint. Emerging trends in turbofan development, more efficient designs. The next generation of turbofan engines is emphasizing the achievement of even higher bypass ratios, the reduction of fuel consumption, and the minimization of noise. Recent developments in materials such as ceramic matrix composites have contributed to the alleviation of engine weight and the enhancement of thermal efficiency. The term hybrid electric propulsion refers to the combination of conventional turbofan technology and electric motors in hybrid engines, which helps to minimize greenhouse gas emissions and fuel consumption. To be more environmentally responsible, aircraft manufacturers are researching hybrid electric systems. Sustainable Aviation Fuel SAF. To assist in the reduction of the overall carbon emissions produced by the aviation sector, several manufacturers are currently working on engines that are configured to operate on alternative fuels, such as biofuels or synthetic fuels. Examples include the Pratt and Whitney-geared Turbofan GTF, which is a type of turbofan. This particular engine is constructed with a geared fan system, which enables the fan to rotate at a slower speed than the turbine. As a consequence, the engine's efficiency is increased and its fuel consumption is decreased. The Airbus A320neo and the Embraer E-Jets E2 are two examples of aircraft that are powered by this technology. Rolls-Royce Ultrafan. Explanation. The Ultrafan is designed to achieve a significant reduction in both the amount of fuel consumed and the amount of carbon dioxide emissions by its enormous fan diameter and high bypass ratio. Rolls-Royce is also investigating the possibility of utilizing SAF with this engine to assist in meeting sustainability targets. Fifth, concluding remarks regarding the prospects of jet engines. This demand for improved performance, greater fuel efficiency, and quieter and more environmentally friendly air travel has been the driving force behind the evolution of jet engines, from turbojets to turbofans. The invention of high-bypass turbofans brought about a revolution in the commercial aviation sector. These aircraft made it feasible for airlines to operate at a lower cost, while simultaneously giving customers a flying experience that was quieter and more comfortable. At the same time that the globe is confronted with the challenge of lowering carbon emissions, the aviation industry is changing its focus toward engine technologies that are increasingly efficient and environmentally friendly. It is anticipated that the future of jet engines will be determined by improvements that value both performance and environmental responsibility. These innovations will include hybrid electric engines as well as the usage of sustainable fuels. Not only does the evolution of the jet engine reflect scientific advancement, but it also shows the resolve of the aviation industry to continue pushing the frontiers of what is possible, both in terms of performance and environmental sustainability. Don't forget to like this video, subscribe to our channel for more amazing content, and drop a comment below.